doing big payouts with koin. So, what is koin? If you pay attention to the Android social media community, you may have seen some stuff on Twitter about it a few months ago. It's a pretty controversial thing for some people. So it's a library that was written by Arno Giuliani in pure Kotlin. Koin 1.0 was released a year ago, almost exactly, and then Koin 2.0 was released on May 22nd. So this is the reason why we had a lot of talk about it in June. We had a lot of performance increases and cleaning up the API and extremely good documentation. And so what does it actually do? Well, it's kind of, it's a library which handles your dependencies. As to what exactly that means, that's debatable. So we're going to be describing how it works using a sample app. We're not going to make a coffee maker. We're going to use this guy where we've got a single screen which uses a single view model, and that view model takes parameters of a user ID and a repository. And then that repository needs a service and a DAO. We're going to assume retrofit and room. And then that DAO is going to need then the room database, and the room database is going to need an application context. Meanwhile, the service needs to be created using a retrofit instance, and that retrofit instance is going to need the HTTP client as well as a base URL. So before we talk about dependency injection and inversion of control, we're going to talk about something called normal control flow, also known as normal flow of control or just control flow. So how we would do this repository back in the day would be to hard-code the dependencies for the service and the DAO. These are the ones which it actually needs. But in order to create those, we're going to need to create, again, that database for room and the retrofit client and the HTTP client. These are all things that we need. And if we don't have any way to get them into the class, we need to construct them. We need to construct them every single time. So this is expensive, there's a lot of boilerplate, and it's really difficult to test, right? So if we had this class and we wanted to write unit tests for it, we would be testing against an actual API, and we would be testing against an actual database. So Rebel can help, and we can do things with like proxies so that we're not testing our actual API, but we're going to be testing actual database and actual API, and that's disgusting. So what we can do instead is, of course, to use inversion of control. And this frequently gets broken down into two different categories. We have service locators and dependency injection. So with a service locator, we're talking about a singleton, which is able to either create a new instance of something or return a singleton instance of it, or return a new instance, which is a singleton if the singleton doesn't exist already. Meanwhile, with dependency injection, we have two different types. There's constructor injection, which everybody knows, or there's field injection. So we'll talk about field injection. So you have a screen, and it needs a view model. Sorry, when I say screen, I'm pretty much copying Kaushik Kopal. There's activities and fragments, and they're pretty much the same thing, so I just always copy screens. If you're creating a screen, then you don't have access to the constructor. But you do, but you can't use it because the Android framework will recreate that screen whenever it feels like it, and it's always going to use the default. So if you put something in the constructor, you're going to have a crash. So what we do instead is create this latent var, and then we'll assign it later using a setter. And the way we do that is to listen to some lifecycle event like onAttach, and then automatically every single time this screen does this recreation step, it's going to call out to some injector object and make a request for it to inject this property. Forgive the poor syntax of this injector. It wouldn't scale very well, but I want to point out that it is not returning the property. It's not returning a view model. It's a function which returns unit or void, and what that means is it's two different requests happening. The screen is asking the injector to do a thing, and then whenever the injector feels like it, it's going to get back to you. It could be an asynchronous thing. It could take a while. So there are three problems with this. The first is that we're making this. We have to make this view model public. We're accessing it from outside using this injector, so that's essentially why. And this is a problem because the view model is an implementation detail of the screen. It's not a feature of the screen that needs to be exposed or consumed anywhere else. It's just something that the screen is using so that it can do its job, which means that it should not be part of this public API. It's a little weird. It's also mutable, which is really weird because the whole idea behind a view model, whether it's the architecture components view model or not, is that it exists longer than the screen, right? You have these configuration changes which destroy the view, and you don't want to recreate all this stuff, so it's cached and then restored. So this thing, which is supposed to be kind of eternal, this scope singleton is still resettable. You could create a new one, which is just, again, stylistically weird. And then, of course, it's late in it. And Kotlin gives us this just because, in some cases we're going to need it, but you get exceptions if you try to access a late init before it's initialized. And without using reflection, which you can't really do in Android, you're just kind of, every time you try to access a late init var, you're rolling the dice, right? Now this screen doesn't do anything significant. It's just garbage code. But imagine a real app with a real late init var with real requirements that change over time. And 6 months from now, we could have some observer using flow or live data or whatever, which as part of its callback is going to access the view model. And what if that observer is firing off like on initialization, and one time out of 100, it's ready to access this view model before the view model is actually initialized. You're going to get crash if it's going to be really hard to debug, which is why we prefer not to do this late bar at all. So moving on, obviously the other type of injection is again constructor injection. And what that means is for a repository, we would pass in parameters for the service and the DAO. But then, how is this repository? How are we initializing this, right? Well, the repository is itself a dependency of the view model. So you could initialize it in the view model, which requires that you have the service and the DAO, and that means that you need to create those dependencies. So you could do this, but this is pretty much the same as what we were doing with normal control flow, right? We don't want to do this. Fortunately, we don't need to because the repository is actually, the view model is actually just a dependency of the screen. So we can inject that service in the DAO and let somebody else worry about it. We can do that. But this is weird because we're creating the repository in the view model, but really the view model just wants the repository, and the service and the DAO are just implementation details of how you get to this repository. So what we can do instead is, of course, just inject the repository itself. And now the view model needs to be created, and this happens in the screen. And we need to get the repository in order to get the view model, and this is where we were before. So now in our user screen, we have this late init var, and we need to use an injector to inject it, and So now we've got the problem with deleting a var, and we don't know how to actually get this stuff. And I'm trying to make a point here, which is that we're just kicking the can down the road with dependency injection. There's the pattern of dependency injection is capable for passing parameters around, but it doesn't actually create them. In order to do that, we're going to use service locators. Let's look at how that solves the problem. So, in our screen, when we want the view model, instead of injecting it, we can use what the lifecycle library has provided with view model providers. So this is actually just the default one with no parameters, even though we have a repository that we need to inject, simply because the code involved with injecting it using a custom factory would not fit on a slide. Sounds lazy. But if we wanted to, we could just create a locator object, which would actually abstract all of that away, so that we're always just calling this locator get user vmol, and all that logic is somewhere else. And now if we were to do this, this means that the user screen no longer has it no longer needs to know about view model providers or all the crazy syntax that's involved in creating these custom factories, which is really nice. And it also means that we could go ahead and use it for everything else, right? If we wanted to have a presenter, we could implement the factory pattern in that locator for the presenter as well. And then we can use this with an inline reified type, a generic type, so that instead of actually having to specify, user_presenter.class or user_presenter: class.java or whatever in order to access it, we can just infer that directly from the, from the parameters. And this is great, but there's a problem, which is that we're now locked into a single dependency graph, right? We have this locator singleton, and it's always going to return the exact same object, which means, if we were to test this, we would still be using the hard-coded API and the hard-coded database and all that gross stuff that we want to get away from. So what we could do instead, which actually our keynote speaker just, no, it wasn't him. Yeah, it was. He just wrote a thing about this a couple of weeks ago. We can have an interface for the locator and then a companion object, and we could create different implementations of this interface, and then at runtime we can set whichever implementation we want, whether that's like the normal one with the real dependencies we're testing. And this is really great. It means that we have pretty clean syntax, and we can automatically infer types, and we can have private vals and lazy properties and different implementations for testing. Somebody should write a library for that. So there's a lot of naming conflicts in our field, right? Context is everywhere, applications everywhere, and most of the classes in the coroutines library start with coroutines, and koin is guilty of that too. So when I talk about koin right here in like the next few slides, just in this scope, what I'm talking about is a normal class, right? So this class is kind of the service locator within the koin library. It has several graphs that it uses to store scoped objects and singletons and factories. And then it has functions for injecting, which is getting a property lazily and getting it itself, as well as bindings, setting bindings and creating scopes. And then when I talk about koin application, this is not an application which uses koin, but it's a wrapper around this koin class, this koin instance. It has a reference to a hard-coded koin instance, as well as definition functions for adding definitions of modules and a logger and that sort of stuff. You can do it yourself. So it's important to note some other libraries will create a My Library application, which is an open class or an abstract class. The idea is that you should make your application class extend it, and then it just gives you stuff for free. That's not what this is. This is not an Android application. It's just a normal class. Speaking of name conflicts, it's a context, right? Next up is the global context. And this is pretty much what you would expect. It's a singleton, but it's a latent var. And it holds the coin application, but you can change at runtime which coin application it's using. And then it just has some utility functions for getting that coin instance back. So what this does is it's a singleton that allows us to have a global scope, but the coin instance itself and the coin application instance are regular classes, which means that you can create multiple instances simultaneously of your coin application and your coin instance by extension, and have different dependency graphs running simultaneously within your app or within your tests. So now let's start looking at the DSL. We have these two functions, start coin and coin application. They do the same thing, except that with start coin, you access that global context and you set your new coin application instance to it. So if you use coin application, you get a coin application, and if you use start coin, you get a global coin application. And then it has this function, create eager instances. I don't have slides about this later, so I'll talk about it in a little bit. When you're defining your dependencies, there's a Boolean flag you can set, which specifies, which states whether you should create an instance eagerly, hence the name, it's a good name. And what that means is, imagine you have like some sort of God class or an orchestrator class that interfaces with a lot of different functionality. And it's something that is crucial to the life cycle of your entire application. Anybody with legacy code probably has one of these. And you want that up and running as soon as you possibly can. Now, with other libraries, you would you'd probably have a latent var in your application class, and you'd create your dependency graph and then immediately inject back into your application class those God classes. And that's really weird. So what Koin allows you to do is you declare this dependency and it'll create it immediately. It'll just get it up and running, but only if you're using the global context. Because if you have, again, like multiple instances of Koin going on, you don't want to have multiple orchestrator God classes competing over the same resources with each other. So do this, and it just works. You don't have to think about it. So let's make some code. Here's my application. It's really good. Let's add some stuff by calling start coin, and then all of the guides say to do this. So let's add Android logger. This will take all the output from Koin, debugging stuff, error messages, whatever, and just print it into logcat for us. But I don't use the regular Android logger, right? Nobody does. We use custom logging libraries, and one in particular, Timber. So you can actually create your own logger. It's really easy. Logger is just an open class, and what this is I just copied and pasted the regular one and then changed log.d to Timber with a tag, and that's it. So now back in our application class we can use Timber, and now Koin will work with Timber. It was really easy. So next up, we want to add a context to our dependency graph, because Android, we have to. And we have a nice convenience function for that. Now our dependency graph has its very first dependency, and that's your Android context. And finally, we're going to want to add modules. So this adds every dependency definition from your project directly into your global coin instance, which is then accessible everywhere. So that's it for coin application and start coin. It's initialized and ready to go, and let's talk about modules. So a module in coin is similar to a module in other dependency injection libraries. It's just a logical grouping of dependency definitions. It's pretty easy to understand. They're flat. There's no hierarchy to them. Let's define our first one. You do this using a module keyword in the DSL, and it takes a lambda, and then you save it off to a top-level val like this, data module equals module. And now we need to add a dependency to it. Everything which is in the lambda is going to be executed, and so what we're going to do here is add a factory. Factory creates a new instance every time you request one. And in this case, we're going to be creating a repository. So in that lambda, we just invoke the constructor, right? Really simple. Every time we request a dependency of type user repository, it's going to look into this, look for this line, and then invoke whatever is in the lambda. So I wanted to point out that this is a DSL, and sometimes DSLs kind of look like magic, and they're not. It's just a regular lambda. You can put whatever you want in there, so long as what it's returning is the type that you're looking for, and it's going to, execute normally. That's fine. But don't do this. Just an example. Another thing I want to point out is I was dancing around what this is actually called. That's because it has a few different names. In the actual code, it's called a beam definition, but in most of Arnaud's videos and articles and things, he refers to them as components. So I'm going to try to remember to call it a component, so that we're not confusing. No promises. I should also say that there are other libraries which have something called a component, and this is not in any way related to that, except that it's, Android and all that. So now we've defined a dependency, and it's time to actually connect it so it's accessible. I kind of danced around this a little bit earlier. This koin demo modules thing is just a top-level val, which is a list of modules. And currently it doesn't have anything in it, but we can fix that. And now it knows about the data module, and anything that you put in the data module is going to be accessible from the graph. I really like having this as a top-level property and having everything exposed for a bunch of different reasons that we're going to talk about later. But since you have the ability to create multiple coin instances, clearly you wouldn't be creating multiple coin instances just from within the on-created application. So they just need to be accessible somewhere. So the problem with this, though, is that the user repository has dependencies, and this one doesn't. So we need to get those dependencies into the graph as well. We need the database and the OKHTTP client and retrofit and the service and the database. And so what we can do is we can take that service in the DAO and put them as constructor parameters for the repository. And also we can make them private instead of public. Earlier we would have needed them to be public so that we could test them. But now we can't create the repository without having access to them already. So, we can clean up our code considerably. And now we've just broken our data module, right? It takes two parameters. So this is how we can add parameters from the dependency graph into a constructor inside the dependency graph. You just call get. Get will resolve the instances eagerly. Because it's an inline reified function, it's able to infer already that the service that it's looking for is user service, and the DAO that it's looking for is user DAOs. Of course, there's a problem that we don't actually have them in a graph, so let's add those. Now, since they have their own dependencies, let's add those as well. And I want to point something out about this. So get is not just for resolving dependencies in your constructors. It's just an inline reified function that's able to resolve an instance of whatever at whatever time you want. So here, in these two highlighted parts, these aren't constructors. These are just retrieving instances from elsewhere and then using them in order to create things, in particular with the user service. So now let's do the same thing with the database, and let's look at this as well. So now we're using Android context for the first time. That's the thing that you just add super easy in your start koin lambda. And also note that for the user DAO, we're not actually calling a function, we're getting a property from inside the room database. Since room already handles that service locator functionality for us, we don't have to do anything extra. So a point about this is it's getting a little bit difficult to read, and certainly in a real-life application with lots of different DAOs and all that kind of stuff, we'd probably modularize this. There's another overloaded term. We would pull this out into different modules, but there's something else that we can do instead, or as well. Instead of having these different clues in all of these different places about what it is that all these vectors are creating, we can use the explicit type parameter to just make everything nice and aligned. The IDE actually gives you a warning about this, which you can suppress, which I do because I think it just makes everything really easy to read. But that's just my 2 cents. So there's another thing about this, which is that it's pretty inefficient. I mentioned that Factory is always creating a new instance of everything all the time, and you really don't want to do that. The OK HTTP client and retrofit and room database, those are super expensive. Fortunately, there's another keyword for these. Single. Single will create a single instance, always. It's a singleton. Back in the day with Koin 1.0, this was, and before, single was known as bean. So if you're checking something on Stack Overflow or looking at an older Medium post, you'll see bean, and you're not going to know what that is. It's the same thing. In fact, now there's a type alias in 2.0 to help with migration. Bean is exactly the same thing as singleton. So now the graph is able to, elements in the graph are able to access other elements in the graph, but that's not super helpful if we can't do anything outside. So how do we do that? Getting back to our screen, this screen conspicuously isn't part of any sort of class hierarchy. We don't extend or implement anything, but it wants a repository, right? So how do we get it? We can do this. Remember, we had that global context, and that global context has a nullable var which references a koin instance, which will actually create one if it doesn't have it. So we global context.get, .coin.get, and then we can pass in the user repository type. So that get is the same get that we're using inside our module itself. But this is really gross. Nobody wants to break all of this. There is a shortcut. Arnaud made a marker interface called koin component, which just has extension functions that will handle all of that boilerplate for you, so that all you need to do is call get. And this is significantly better. But it gets better because we're Android developers. And he wrote the same extensions for component callbacks, and there's some for lifecycle loading that if you're already extending fragment or activity, then you get the same functionality without having to implement anything else. Oh, and services, Android services. But of course, the screen shouldn't be dealing with repositories. That's the view model's job. And so we should create a view model as well. So let's create a new module, and we can do this using a different keyword called view model. This is part of the Android library for koin, and it does practically the same thing as view model providers, but it handles all the lifecycle stuff itself without actually leveraging that library. It's not a singleton and it's not a factory. It's scoped to the lifecycle of the screen that's requesting it. And now we can add this module to our list of modules. And from our screen, we could do this. Just use that get keyword again. Except this is a fragment, and you definitely don't want to do this because the lifecycle that you want it to be linked to isn't created until on activity created, right? So what we usually do in non-koin code is we create a val with a by-lazy, right? And then that by-lazy's lambda would access view model providers. And again, we're not using view model providers, but we do have this view model keyword. And this view model keyword is again going to access the graph with a scope related to the lifecycle owner that's calling it, and return the view model that's requested, whether that's a new instance or an existing one. So, oh, and it's lazy, right? So this does, just pointing that out, like you could break this if you had an init block or something that immediately accessed it, but so long as you maintain the same conventions that you have with like normal lazy initialization for a view model, then you're fine. And you can do the same thing with any other property. Clearly you can't get a presenter or a repository using the view model keyword, but by inject does the same lazy functionality. So the thing is though that I mentioned when I was showing the initial dependency graph that there's a user ID associated with the view model. And how do we do that? How do you do dependency injection and parameters, dynamic runtime parameters? There are other libraries that are really bad at this. So what we can do is, so here's our code, and we want to add the user ID to the user view model as a constructor parameter. And now we have to add that to the module definition. So I said before that the module definition is just a lambda and it's not magic, which means that you can define a lambda which takes parameters. And the magic of koin behind the scenes is that it will destructure your lambdas and put them into objects, which it can then restructure. Maybe it'll structure them and then destructure them. It'll take your parameters, put them into an object, and then when it needs them, when it's resolving the graph, it'll pull them out. So if we want to add the user ID, we just write a normal lambda that does it. And now in our screen, instead of using parentheses, parentheses, we just use a lambda and pass in this parameters of object with our dependencies. If you think about how other libraries handle this, this is significantly better. This was, when I saw this was the moment that I decided that I would switch to koin. So now let's talk about scope, right? We're talking about a user ID, and that's not something that it's not global, and it's not like a single instance, right? So those are the two graphs, the two scopes that we've been talking about already. This is something in between where you want it to last for a while, but if your user signs out, then that scope goes away. And we can do this using another keyword called scoped. Scoped will invoke a new builder that anything that's defined within that scope lasts for the life cycle of that scope, and then anytime you're within the scope and you request an instance, it'll pull it from that scope if it already exists. But then as soon as the scope is closed, the user has logged out, all those instances are wiped out, and you'll need to create a new one. So we've created this module for scoping and added our preferences. Let's add that to the graph. And now we need a qualifier that we can use to identify what type of scope that is. So qualifiers exist in other libraries as well. It's a little bit different in koin. The way I like to handle these is I'll make an empty object, and then I'll write extension functions on it, so that I can anywhere in my application I can extend it and then access that login from anywhere, I guess. So we created that scope. So we've created this login qualifier, and now we've created a scoped object, and we need to tell koin how to associate those scoped objects with something, and that's what the qualifier is for. We have this additional parameter. So when you're looking for an object which exists in the scope, koin is going to look at the qualifier that you're calling it with and match them up. And now we have to add that to the graph. And now when we're actually trying to use it, we create a scope using that qualifier, naming it whatever we'd like. And instead of calling get or inject preferences, we reference that scope and call it from that scope. So like the no-arg get or inject is pretty much like a global scope. Unlike other global scopes, it's something that you should use most of the time, but it's just like a mental model that you can access things from within other scopes, such as this login scope. And of course, because we're Android and everybody loves us, we get something special. Instead of always creating these scopes, we have extension functions to do this with our lifecycle components. So current scope is going to return a scope created using the name of the screen. And this can be your activity screen if you're doing single activity, multiple fragments. It can be the particular fragment that you're on. And then in your scope module, you just create a scope looking for that name, my activity or my fragment or whatever. And again, anything that you put inside that scope will be returned as like a singleton or a scoped instance throughout the lifecycle of that screen, and then at the end it will be destroyed. So it's really, really easy. There's also I didn't include it, there's a shared view model keyword which does the same thing for like an activity view model that you want to share with multiple screens. So next up, we're going to talk about dynamic features. This is a little bit tricky, and I know not a lot of people are doing it, but if you have dynamic feature modules, the application isn't allowed to actually know anything about that graph on application launch, right? The feature module doesn't exist yet. So how do you add that stuff to the graph? Well, as I mentioned, you can load and unload modules whenever you want. You can change koin modules whenever you want. So what you're going to do is in your dynamic feature module, you have another one of these top-level valves, which contains a list of modules that are unique to or specific to that dynamic feature module. And then you're going to create a val, a lazy val, with a lambda. So this is actually a valid type unit, but in its builder, it's going to invoke the load koin modules function, and that will add those modules to your existing global context. So then you can add a simple function, init modules, which just accesses that and returns a unit. And now, in the screen, which is the entry point to that dynamic feature module, whatever activity that is, in its init, you just want to immediately access that, or call that function, which will then immediately add all those dependencies to your graph, and you can go on with normal dependency injection really easily. So I mentioned testing a few times. I love testing. I spend more time writing testing on my code, and one of the common concerns about testing is overriding modules, right? This is really, really hard for dependency injection library to do, normally. So let's say we have a test, and you're testing your repository. You need the service and you need the DAO in order to create the repo. You'd have to create these objects yourself. I'm using Mach-K, which is awesome. And you've got to create all this boilerplate in order to generate your dependencies. What we can do with koin is use another marker interface, koin test, and what this does is give us access to that entire global context dependency graph. And so now, in our before each or in our setup function, we would start koin, and we would load all of our modules, which is fine because it's just lazily evaluated anyway. And then we're able to get our repository directly out of that dependency graph without doing any additional setup. And then we need to remember when we're done with our test and our cleanup method to close koin. So it's really simple, but there's more. I mentioned overloading modules, overriding modules. You can create a module, and there's another. We have two booleans. The first one is that creating instances, and the second one is this override. If you take either an individual component or the entire module with override, then that will override. Really good name. So now we can create mock instances of our DAO and our service, and in our testing we can access those without having to do any additional setup. Everything else will be normal except for those. All right, and you have to do this. You have to add the mocks module to your graph. So got ahead of myself. So the last thing is checking the graph. This is something that koin gets hit on kind of often. That we don't have that compile time dependency, the compile time checking, and that's true. But I don't run all of my unit tests every single time I do a local developer build. That would be insane. So why does my dependency graph need to have special treatment? It doesn't. Instead, we can call a simple function called check modules. And this check modules function does exactly what it says it does. It will not check the get or the by inject or the by view model that you have in your screens. It has the same issues there that other libraries do, but what it does do is it goes through every single definition that you have in any module anywhere and verifies that every single one of them can be constructed by something else which is in your module. So this single test does everything that you want it to do in terms of validating, what it also gives you is half what you built to come back. So that's it for Koin. Thank you so much. Try it out yourself. It's fast, it's easy, it's accessible. It's really, really great library. Here's some documentation. There's a lot of documentation on Koin. Read the Android documentation, read the core stuff, check it out on GitHub. And again, that's it. I'm Rick Busarow. Here's my social media. I'll be tweeting my slides momentarily. If you have any questions about anything, I'm always happy to answer. And that's it. Do we have time for questions?
Sorry, you don't have time for questions. Hands of applause, please. Thank you. Rick will be around, so please, let's move to the next section, please.
Like I said, you don't write more with these because you go back to that security.